Hey everyone, I hope that you're going to have a great day today. I'm going to try to help out with that just a little bit. So here's what I want you guys to do. If you got your homework out when you first came into a room, like we normally would, I want you to put it away and I want you to hold on to it until Monday. On Monday, not only will we go over what we're going to be learning today, but we're also going to go over any questions that you have over the theoretical probability. So I'm actually going to be checking both of those assignments on Monday, and then we'll spend the rest of that time just making sure we're good. Okay. So that's what you can look forward to on Monday. You won't have to worry about me teaching a bunch of stuff and getting homework. We will just be going over the problems that you have over theoretical probability and, as you can see here, conditional probability. Now, I know your sub has given you this paper. It was the first thing that they did. So we're going to go through these notes, and then after we're finished with this, then of course you're going to have some time to work on the assignment. So maybe even you could get done with it before the weekend. And then also, or if you choose not to do that homework assignment with the time that you have, you can finish up your project, which is due today. So you better get that thing done because it's due before you leave today. So conditional probability is what we're learning today. Okay, conditional probability. So let's get to it. Given events A and B, conditional probability is the probability of event B occurring, knowing that A has already occurred. Okay, it's already occurred. So it's not quite like, I spelled that wrong. It's not quite like what we learned yesterday. It's a little different. So let me explain, okay? The designation is the probability of B given A. And that's exactly how we would read it. It's the probability of B given A. Okay, now the technical definition, or not definition, but formula that you would use for probability of B given A, you would actually do the probability of A and B. So two events, multiple events, we multiply events, and then of course divide that by the probability of A. Now, if you think about this for just a minute, well, the probability of A on the top and the bottom are going to cancel. So basically, our focus is going to be the probability of B, given that A was taken into consideration. Okay, so let me explain. Okay, look at number one. Mitchell drew a card from a standard deck of playing cards. Now, I know we talked a little bit about playing cards. You know that generally there's 52, right? 52 cards. It says, what's the probability that he drew a queen given that the card was red? So look at this, guys. We're doing the probability that he drew a queen given that it was only from the reds. So pause. I want you to focus on the given. Okay. When we do this, I think that needs to be the key. We're going to focus on the given, the fact that it's red. How many cards out of this total 52, how many were even red? Well, you know that half of those, right? Only 26 were actually red. So when I focus on the given that here, there's only 26 cards that are red. Now, ignore all the black ones. Ignore all the black cards. No more spades, no more clubs. You're only focused on these reds. Out of those two suits, okay, hearts and diamonds, out of those red cards, how many are actually queens? Just two. So my probability that I draw a queen, given that the card was red, so eliminate blacks, given that they're red, it is 2 out of 26, which will reduce to 1 out of 13. That's conditional probability. Okay? Let's look at some more, okay? Make sure you understand this. A number from 1 to 100 is randomly selected. Now, let's pause for a second. 1 to 100, of course, would include 100 minus 1, 99 plus 1, because it's included. So you're talking about 100 numbers here in this particular thing. It says, what's the probability that it is a perfect square given that it is an odd number? Okay, so look, when I talk about the probability that it's a perfect square, so I'm just going to put PS for perfect square, given that it's an odd number. So here's the deal. Out of all these numbers we talked about, these 100 numbers, we're only dealing with the odd ones. Now, you know how even and odds work. If there's 100 numbers, since it goes even, odd, even, odd, even, odd like that, if there's 100 numbers, there are going to be 50 of them that are odd, right? So we're only focused on the odd numbers. That's it. So here's the point. Let's do or think about all of our perfect squares from 1 to 100. We've got 1, we've got 2, 3, 4, we got 4, 2 squared. We got 16, we got 9, sorry, 16, 25, 36, 49, 64, 81, and 100. Right? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squared. But here's the deal. Am I talking about all those perfect squares? No. Remember, we're only talking about the perfect squares given that they're odd. So 4 is even, it's out. 16 is even, it's out. 36 is even, it's out. 64 is even, it's out. 100 is even, it's out. It can only be from those numbers from 1 to 100 that are odd. So it can only include 1, 9, 25, 49, and 81. That's 5. It can only include 5 out of those 50 odd numbers. Well, 5 divided by 50 is 1 out of 10. I hope that makes sense. Okay. I think that's the easiest way to go about this. There, is another way where you specifically follow this formula, but I like to think about it from more of a logical standpoint. Okay. Number 3, there are 62 people that take a yoga class and 48 that take a spinning class at the gym. 15 people that take yoga also take spinning. If a person from these groups is selected at random, find the probability that he or she is taking yoga class. If you know they take a spinning class. Okay, so this is pretty confusing. So I want you guys to consider what we're dealing with. We're dealing with people who take yoga. We're dealing with people who take spinning, and we're dealing with people who take both. So what I want you guys to picture in a situation like this is overlapping circles. Okay? If I overlap a couple circles, I want you to understand what that's representing. One of them is representing the people who take yoga, right? And one of them is dealing with people who take spin. Now, in my opinion, it's easiest to start with how many people take both yoga and spinning. Well, it said it right here. There are 15 people that take both. Okay. So I'm going to put my 15 right in the middle, and here's why. How many people take yoga? Well, it says 62, right? But out of those 62, you had 15 that were in both categories. So how many would actually just be in yoga? Well, it'd be 62 minus 15. So we have 47 people who only take yoga, right? Because 15 take yoga and spinning. So 15 out of those 62 leave only 47 who do just yoga. So let's do the same thing with spin. It says that 48 people take a spinning class. Well, yeah, but 15 of those also do yoga. So 48 minus 15 will leave me with only 33 who only do spin. Okay? All right, now stay with me. Here is the question. It says, if a person from these groups is selected at random, find the probability that he or she takes yoga if you know, okay, given that they take spin class. So here's the deal. Excuse me. We're finding the probability that they take yoga given that they take spin. So we're only dealing with people who take spin classes. Well, remember, these are the people who take spin classes. Am I right? 15 and 33. That's 48. We're only dealing with a bottom number here of 48, right? We're only dealing with the people that I highlighted in blue. So here's the point. Out of those people who are in the blue, how many of those take yoga? Well, that's the 15 that were in the overlapping spot. So 15 out of 48 are the ones who take yoga if you know or given that they take spin. So 15 out of 48 will actually reduce if you use your calculator. It reduces down to 5 out of 16. So 5 out of 16 take yoga knowing that they also take spin. Okay, kind of crazy. Maybe that's simple to you. Maybe you are challenged with that. So let's do a couple more. Of the 30 students in Mrs. Smith's math class, there are 13 are athletes, 9 are in band. So there's 30 total students in math class. 13 are athletes and 9 are in band. 3 of the athletes are also in band. If one student is chosen at random, find the probability that the student is in band if it is known that they are not an athlete. Okay, so here's what we know, y'all. We know that there are 2 categories, right? There are 2 categories. There's also overlap. Those 2 categories are what? Athletes and then band, right? Now, again, like always, like I did earlier, I told you that I like to find the ones that are right smack dab in the middle. Who is both athletes and in the band? Well, there was 3 of them. 3 of them go right there, right? But it also tells me that in this class, in this math class, 13 people are athletes. Well, remember that includes the 3 that are both. So how many are just athletes? 10. And then, of course, there's 9 in the band, but that includes the 3 that are in both. So how many are just in the band? 6. So here's my little comparison between athletes and band, and then those who are in the middle for both. And here's what the question says: if one student is chosen at random, find the probability that this student is in band. Okay, so we're doing the probability that they're in band, given that, see, it is known that they are not an athlete. Not an athlete. Now that's going to be tricky. Okay. How many did it say were athletes? See, we're only dealing with uh, not athletes. So how many did it say were athletes? Well, there was 10 and 3, right? So there's 13 who are athletes. But how many kids are in the class? Well, there's 30 kids in the class. 13 are athletes. But not athletes would be 17. So we're only dealing with 17 people. And this time, they cannot be in that circle right here. Okay, they're not athletes. So, how many are in the band that are not athletes? Well, that's right here. 6. There are 6 out of the 17 students that are still remaining in Miss Smith's math class who are not athletes. Okay? There were 13 who were, there are 17 who are not. So we dismissed this circle this time, and now we're talking only about these 6 who are in the band who are not athletes. Okay, I hope that makes sense. Okay, now once we get into this next portion, I really think things get a little easier because it kind of pinpoints things just a little bit, and you can kind of figure out what you want to focus in. It says the table shows a result of a poll of 50 randomly selected students who were asked whether they prefer to watch hockey or football. And they want me to find each probability. Now, look, if I were to take 18 and 10, 6 and 16, and add all those up, that's 50 total people, okay? Everybody's included. But I want you to notice here it says you want to find the probability that you prefer football given that you are a girl. Okay, so we're finding those who are preferring football given that they're a girl. Here's what I want you guys to focus on: the given that. See, if we're only focused on the fact that they're coming from the list of girls, we are only dealing with these two categories right here, 6 and 16, right? We're only dealing with that right there. So what's my bottom number? Well, what is 6 plus 16? That's 22. We're only dealing with those 22 highlighted people. Now, of these 22 highlighted people, who prefers football? Well, that's these 6 right here. See, prefers football. So it's 6 out of 22. Now, if it will reduce, we want to. And this does, it reduces to 3 out of 11. And that's my answer. Now, let me erase this because we're going to start over. Look at the next one. We want to find the probability that's a boy given that they play hockey. Remember, our focus is the given that. We're only focusing on people who play hockey. We're only focusing on those two people right there, 10 and 16. We're only focusing on those 26 people. Now, of those people who prefer hockey, of those 26 people who prefer hockey, how many are boys? Well, that's 10. So it's 10 out of 26, which again will reduce to 5 out of 13. That is conditional probability. You're only limiting your probability to a certain group of people, okay? Now, with that being said, we come to another problem, number 5. And there's 150 people. Again, if you were to add all these up, if you tallied every one of these, that's 150 people. So you got these kind of groups. You got 6th graders, you got 7th graders, you got 8th graders. But then you've got 6th graders, 7th graders, and 8th graders who all take French. And you've got 6th, 7th, and 8th graders who all take Spanish. Now, you got to pay attention to what your wording says. This says, hey, what's the probability that you have a 7th grader who takes French? Now, again, does this say given that? No. We're just trying to find the probability of a 7th grader who takes French. Now, look, where is that? Where is a 7th grader who takes French? That's right there. That's 25. Well, 25 out of what? What's my bottom number? Well, there was no given that, was there? So if we're just trying to find the probability of a 7th grader who takes French, that's out of the total. So A is 25 out of 150, which obviously reduce, and it reduces down to 1 out of 6. But now notice what happens with the rest of these problems. B, find the probability of an 8th grader given that they take Spanish. So we're only focused on the given that. We're only focused on people who take Spanish. Well, look, guys, here's the group of people who take Spanish. That's my focus. Now, 23 plus 12 is 35, and 35 plus 33 is 68. For this problem, my bottom number is 68. Now, from that group of people who take Spanish, remember, given that they take Spanish, from this 68 people who take Spanish, how many are 8th graders? Well, that's 33. So 33 over 68. Now, I tried it. I don't think that reduces. So there's your answer. Okay? Easy stuff. This is called conditional probability. Look at C. Probability that someone takes French given that they are a 6th grader. So again, what's my given that? 6th graders. I'm only focused on my group of 6th graders. That's this category right there. I'm only focused on 19 plus 23 people. I'm only focused on those 42. 19 plus 23. Now, from that group of 6th graders, I am really only focused on those that take French. That's 19. 19 over 42. Again, that won't reduce. You can try it if you'd like. That's my answer. I hope this is starting to make sense. Look at the next one. We're going to try to find the probability of a 7th grader given that they take French. So once again, we're thinking about those who take French. That's this category. 19 plus 25 plus 38. And that's 82. There's 82 people in the bottom of this one. Now, from that group of 82, how many are seventh graders? 25. So it's 25 out of 82. And again, I don't believe that one. No, it doesn't reduce. So there you have it. Conditional probability. You're limiting your probability to a certain group. And from that group, you're identifying a specific characteristic. Okay. Last one, number 6. This table shows the results of a poll of randomly selected juniors and seniors who were asked if they attended prom. Now, the only problem with this is they don't give me a total. So I'd encourage you guys, since they don't give me a total, just to go ahead and look through it, add it up. 28 plus 56 plus 97 plus 19. That's 200 total. That might come in handy, okay? 200 total. So look at A. Find the probability of a junior that did not attend prom. Again, notice there's no given that. There's no given that. So are we limiting our group? No. If they don't give me a given that, we're looking at this person out of the total. So my bottom number on this one's going to be 200. Now, out of the total, where's my juniors that did not attend prom? Well, that's the junior no right there, 56. So that's 56 out of 200. Now, will that reduce? Absolutely. To 7 out of 25. Okay? Now, next one, it does clarify. It does give a condition, right? It definitely gives a condition. It says, what's the probability that they did not attend prom given that they were a senior? So we're only dealing, y'all, with this group of seniors right here. That's it. So we're only dealing with 97 plus 19 of these people. We're only dealing with 116 people. Now, of those 116 people, how many did not attend prom? 19. 19 out of 116. That is also prime. 19 is, so it won't reduce. Now, last thing, let me put that number back up just in case we need it in a minute. I don't think we will. What's the probability that they're a junior given that they attended prom? Again, this is my focus. When they give me those given that's, that becomes my focus. So I'm only dealing with those that attended prom. That's the yes right there. That's 28 plus 97 people. That's 125 people. Do the math. Now, of those 125 people I've highlighted, that group that attended prom, which one are juniors? These 28. So it's 28 out of 125. So that's it. That is conditional probability. Maybe a little thought goes into it. Maybe you'll struggle with problems like number 3 and 4. Maybe you'll struggle with these two-way tables. But that is really all it is in a nutshell. So here's what I want you guys to do. On the homework page that is coming your way as we speak, I want you to do, and you might want to highlight these, I want you to do number 2, 4, 6. I want you to do 7, 8, and 9. I want you to do number 10. I think you'll struggle a little bit with 10. I want you to do number 10. And then on the back side, I want you to do number 12 and 13. Okay? That's it. 14 is frequencies, and we're not going to do those today because I want to give you guys just a little bit of time. So it's 24 minutes. That means you have about half your time left. So 2, 4, 6, 7, 8, 9, 10, and then 12 and 13. Okay? And hey, listen, by 12 and 13, I mean all of these. All right? All of them. So don't try to skip out. So remember, on Monday, I will go over any of these that you have questions about, as well as the theoretical probability homework that was due today. I'll be checking both of those on Monday. All right? I hope that you guys have an awesome weekend. Go Raiders.